Alright, and welcome to Graphing Rational Functions, Level 2. Now, in our first example, we want to graph f of x equals 3x plus 2 over x minus 4. And notice something, this is actually a little bit different than functions we've analyzed previous, in that you'll see here on the top we have 1x, see that 3x, and on the bottom we have 1x. And so when we have the same amount of x's on top as the same amount of x's on the bottom, we actually call this a balanced function, okay? And so when we look at this, we see it's balanced. Well, how does that affect our asymptotes? It really affects the horizontal asymptote. So, what do we do for this? Well, we take the highest degree of x, which is in this case 3x, and the highest degree of x on the bottom, which is x. And so we will write 3x over x. We will essentially divide the two. Now, what is 3x divided by x? Well, the x's go away, and we are simply left over with 3. And so it turns out that is actually our horizontal asymptote. We can no longer initially set our horizontal asymptote to 0. With the balanced equation, we have to look for that ratio. Let's go ahead and look at our vertical asymptote. So just the same as in our previous examples, we look at the denominator, which is x minus 4. And of course, we want to find out where does x make that factor equal to 0. So we set it equal to 0, and what is the opposite of minus 4? Well, of course, that would be plus 4. And so we know that x equals 4. And of course, this will be our vertical asymptote. So we now have enough information to go ahead and graph this particular function. Let's see what it looks like roughly. So I'm going to switch to a red, and our horizontal asymptote is at positive 3. And our vertical asymptote is at positive 4. 2, 3, 4. And now that we've drawn our asymptotes, well, of course, we go to our very next question. And our very next question is our function ultimately positive or negative? And since there's no leading coefficients that are negative, we know that it's positive. That implies that our rational function will be these curved lines kind of in this upper right quadrant, we'll call that quadrant 1, and this bottom left, which will essentially be a quadrant 3. And remember, these lines get infinitely close to these dotted red lines, these asymptotes, but they never cross. Now, what does that mean for our domain? Well, let's see. So our domain, if we look all the way to the left, is extending to negative infinity, comma. And as we go towards the right, what is this value that we're approaching? Well, it's our vertical asymptote, which approaches the value of 4. So that is the left side of our function. And we write this u, which represents union, meaning we're going to say, hey, here is the left side of our function. That's its domain. And then on the right side, we see, hey, this picks up right on the other side of 4 and then approaches positive infinity. Okie doke. Now let's go ahead and look at our range. Okay, so our range, let's see, how low does this graph go? If you were to look on this graph and try to find the lowest value, we see it's extending towards negative infinity. And as it goes up, what is this value that it's approaching? Well, it's approaching the horizontal asymptote of 3. Union. And see over here on this right side, we start on the other side of 3, and then of course we continue on up to positive infinity. I would recommend that you pause this video, finish writing down any notes that you're taking, and let's go ahead and move on to our second example. Alright, let's take a look at example 2. We want to graph f of x equals negative 5x plus 2 all over x plus 7. Now, the first question we want to ask, is this bottom heavy, balanced, or top heavy? And notice, because we have a 5x on top and an x on bottom, since there's one x on top and there's one x on the bottom, we will of course call that balanced. Okay, so how does that affect this graph? Well, I go to my horizontal asymptote, and remember, when it's a balanced equation, we take our two leading terms, that 5x over x, and we want to divide them. However, something to be acutely aware of is we have this negative in front. So what we want to do is we actually want to put that negative with our numerator, And so it turns out negative 5x divided by x would give us negative 5. So this will in fact be our horizontal asymptote. Now let's go and look at our vertical asymptote. We of course look at the denominator, x plus 7, and set it equal to 0. And so we just want to solve for x. How do you get rid of a plus 7? Well, of course we'll do minus 7 and minus 7. And this will give us x equals negative 7, which of course will be our vertical asymptote. Now at this point, once you have your two asymptotes, you have enough information to graph your line. So let me go ahead and draw our x-axis and our y-axis. And all we have to do is graph our vertical and horizontal asymptote. So our horizontal asymptote is down here, 1, 2, 3, 4, 5. And our vertical asymptote is over here, 1, 2, 3, 4, 5, 6, 7. Oh, oops. Those should be dotted. You know it. Just pretend it's dotted. No mistakes. Alright, so we now have this, and we look at our function, and we want to ask ourselves, well, is this positive or negative? And in fact, since it's negative, we know they'll be over here in this top left and this bottom right. I know this one's a little bit more cramped, my apologies, but we'll have our graph looking something like this. Because that negative ultimately reflects it over the x-axis, it flips up and down. And so our graph is now in quadrant 2 and quadrant 4. Okay, so how does this affect the domain? Well, we see all the way over here to the left, it's extending to negative infinity. And as we go towards the right, we're approaching negative 7, our vertical asymptote. And of course, on the right side of negative 7, we pick right up where we left off, and we go from negative 7 to infinity. Let's take a look at our range. Okay, well, how low does this graph go? We see it goes all the way down to negative infinity, and it's going up, 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 and it approaches negative 5, at which point it takes a little break. And on the other side of negative 5, of course, it goes on up to positive infinity. I would encourage you to pause this video right here, go ahead and finish writing out your examples. Let's go ahead and move on to our third example. Okay, here we are in example 3, and we want to graph f of x equals negative 3x minus 7 over x plus 1 plus 6. Our first question is this a bottom-heavy, balanced, or top-heavy equation? And seeing as how we have one x here and one x there, so one x in the top, one x in the bottom, we know it is in fact balanced. Now how does that affect our horizontal asymptote? Well, when we have a balanced equation, we have to take our leading coefficients, or our leading terms. So we'll do 3x divided by x. But once again, you have to ask yourself, hey, do we have a negative out in front? And where does that go? Well, that will go on top. So we have negative 3x divided by x, which equals negative 3. However, if you'll notice, we also have a constant being added on the outside of this function. So remember, any constant that is being added or subtracted will shift your graph up or down. Well, if our horizontal asymptote is at negative 3, we then have to add 6, whatever that constant is, to it, in order for us to get our horizontal asymptote is actually at positive 3. Now let's take a look at our vertical asymptote. As always, we look at the denominator, this x plus 1, and of course we set it equal to 0. So let's ask ourselves, what is the opposite of positive 1? Well, that would be negative 1. And so x equals negative 1. This will of course be our vertical asymptote. Let me go ahead and draw my graph a little bit further to the right this time so it's not so cramped. And let me switch this nice red so that we can go ahead and look at our horizontal asymptote. So I come up here, 1, 2, 3. Remember, positives go up, negatives go down. And on our vertical asymptote, our negative will send us to the left one. Okay. And now once we've drawn this, we can now go ahead and switch over to graphing this function. Now notice once again, if it were a positive function, we'd be here in quadrants 1 and quadrants 3. However, this is a negative function which reflects it into being in quadrant 4 and of course quadrant 2. Now at this point, writing our domain and range will be very, very simple. You should be kind of a pro at it at this point. We see on our domain it is extending to negative infinity all the way up until this vertical asymptote at negative 1, union, let me try and squeeze this down here, negative 1 where we left off, going all the way to positive infinity. And let's go ahead and talk about our range. How low does this graph go? Well, we see it going down all the way to negative infinity, and it's going up and approaching positive 3, which is our horizontal asymptote, union, and look on the other side of it, it picks up on the other side of positive 3, going all the way up to infinity. Alright, I hope that these 3 examples have helped you out, and good luck. I'll see you guys in our level 4 video.